Purpose of this video is to show some of the features of Excel in terms of things it can do that help with exploratory data analysis. So we're going to be looking at and doing 8 different tasks. So first we're going to create a histogram, then we're going to look at a time series line plot and how to create that. Then we'll create a box and whisker plot. We'll find some descriptive statistics using some features in Excel. We're going to examine those statistics to see whether we can judge whether a distribution is normal or not. Then we'll create an XY scatter plot, add some trend lines to it. We'll create a correlation matrix and also run just a very simple regression. So let's go ahead and get started with the first task, that is creating a histogram of data. So the first thing I want to do, I have here, there are a number of different worksheets in this particular file. I'm going to look at a worksheet that has test scores in it. As you can see right here, there is the tab for test scores, so that's the data we want. You can see this includes a bunch of student ID numbers. We'll say these are made up student ID numbers. This is all hypothetical. And also the scores in this particular exam. It looks like it was possible to earn half points. You can see the scores max out, I think in the 90s somewhere. Right? Yeah, so nothing over 100. So it looks like it's probably a standard 100-point test. All right. So the first thing I want to do is create a histogram of this data. So to do that, I'm going to highlight the score column. You can do that simply by clicking the B here. That'll highlight the entire column. And Excel is smart enough that it's only going to consider the data in that column when it makes this graph. The next step to add the chart is to choose Insert, and then Charts is a rather significant part of what we could insert. Near the center of that, you see what looks like this bar graph here with 4 blue bars. That is telling you to insert a statistic chart. Click on that, and you have options for histogram and box and whisker. We want that first histogram option. You can see it already previews it for us. So here we go. I'm going to zoom out just a little bit so we can see what that chart looks like. Right, so here's our chart. This is a bar graph, so each of the bars indicates how many observations are within the range indicated in that axis. This is not a bad start. The automatic settings that you have for histograms in Excel tend to be reasonably good, but not great. Right, so in this case, some of those automatic settings would be it figures out how many bars that you want to have. Normally, you want somewhere between 5 and 20, depending on the data that you have. It apparently decided that 7 was the right number here, and the big thing you were looking for is, does it allow me to see the overall shape of the data? And here we do get a sense of overall shape. We know where the peak is, and we can see how the data is distributed on either side of the peak. Now, one thing that I will want to tweak, though, actually, there are a few. So first, the groupings are kind of weird for human beings. So ranging is from 34 to 44, 44 to 54. The ending is in 4 is strange to a human, at least to this human. And so I want to change those bins in the exact way that they're arranged. So to do that, I'm going to double click on the horizontal axis, and that opens up this format axis window over to the right. So that a few things about that. When you double click on it, normally it's going to go to this option where it says Axis Options. It might also possibly at times go the wrong place. You might end up with a fill-in line, and then you can affect what the color is. For example, you can change that if you wish. Or it might say their effects, so you can add shadows and the like. Generally, that's not a good idea, honestly. It often makes things harder to read. But axis options is what we want. So if you end up somewhere else, you may have to click on what looks like the bar graph there to get your axis options. So inside of those options, the first thing that it lists is bins and how bins are created. So one could be created by category. So if we have divided our data up into categories, then it would use those categories. In this case, we haven't, so we won't. Next would be the automatic option, which is what it immediately did. That's fine. Next would be bin width. So bin width, there we can define how wide we want the bins to be. That is something I will want to play with here in a moment. The next thing would be the number of bins. So if we decide we want to decide how many bins there are going to be, we can play with that and get a sense of the shape of the data. Another two options we can turn on, and we are going to turn one of these on later, is having an overflow and an underflow bin. And so what these allow us to do is that, especially if we have an outlier one way or the other, this is a good way of not having it way off to the right or way off to the left. We'll just capture everything below a certain value or above a certain value. So I'm going to play around with this. 'Cause remember, my complaint is that the shape is fine, but ending in fours feels weird, right? So I do want to deal with that. Well, the first thing I want to do, let's go ahead and change the number of bins. So it automatically made 7 bins. So I click on it now, and now you see when I say number of bins, it's keeping those 7, but it changed the numbers for them to things that look totally wacky. If you look in close, okay, it starts at 34. 34 is the minimum in our data, so that's where that came from. And then here it looks like it's dividing things up. The way it would typically do this is it looks at the minimum and then the maximum, and then divides it up into these 7 equally sized bins. So in this case, that creates these weird decimals like 43.21428, but that's an extremely unfriendly number to a human being's mind. But right now, all I'm trying to do is get a sense of, does this number of bins show me the overall shape of the data reasonably well? Right, so I'm going to try adjusting this a little bit. So that's what 6 looks like. I'm sorry, that's what 7 looks like. Here's what 6 would look like. Oh, 6 actually looks a little bit better, doesn't it? That's not bad. Okay. And then 5, right? 5, yeah, also not terrible. 4. See, now with 4, at this point, I think we're getting to where we're just not getting enough information. There are too few bins, and as a result, as you have too few or too many bins, what ends up happening is you end up with what looks like a very flat distribution. So in this case, you can see for these 3 uh, that are on the right, there's very little difference between those 3. And there is one that is certainly a peak above the other 2, but it's much closer to them. On the other hand, let's say it increased the number of bins. Let's do something crazily large, like 20. Okay. So 20 here, we do have some sense there is probably a peak somewhere in the middle here. We see there's a certain flatness here. The bins simply aren't wide enough to capture a lot of data. Right? So we will want to go somewhere in between. Right, so let's go back to, I said 6 look really good. Right, so now again, these numbers are weird. 34, 44.75, that's not great. So I want to affect that. So here's how I'm going to do that. First thing, now that I've found the number of bins, that gives me a bin width that it shows. So it decided 10.75. I want to stick somewhat close to that, keep it a number a human likes. As a human, I like 10 as a number. So I'm going to put 10 in there. That will naturally change how the bins look. So this is what was originally automatically created, remember? So we still need to deal with my complaint, this 4s. How do we get rid of that? So in this case, our solution is going to be creating an underflow bin. So I'm going to click on underflow bin. Now it automatically put it a little bit below the minimum value, which means there's nothing to go in that underflow bin. If there's nothing to go in the underflow bin, then it's not going to create it. So what it's trying to do now is it's looking at the data saying anything less than 30 we're going to stick into a bin. The lowest number is a 34, so this isn't going to work. So I need to increase this number. I'm going to make it a 40 instead. And that will actually have something in it. You see there, it did change the shape some. So now we have, the first bin is everything 40 or less, then 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Right, so these numbers are a lot more friendly to me as a human being. I like numbers that end in 5s and 0s. And the way we got that, remember, was by forcing, right, the underflow bin to be something that's a multiple of 10, and then having a bin width that's a multiple of 10. And so that gives me a graph that looks reasonable as far as that goes. Another thing we want to do is, because right now the axes are totally unlabeled, the title of the chart is chart title, which isn't particularly useful. So I'm going to double click on chart title a couple times, and that'll then highlight part of it. I can delete what says chart title and put in something else. Let's make this test score distribution or something like that. Distribino, no. Distribution. Another thing I want to do is I'd like to add axis titles. So if I click on here again, see it gives me this plus for chart elements. So I hit the plus here, and then I can add in other things I want, like an axis title. So I click axis titles, and now it has just generic axis title on each axis. Right, so I'm going to put on the vertical axis, I'm going to change this to frequency, since that is what it's showing. And then underneath, I'm going to put score range. So we know it's test scores, that's in the title of the chart. So now this is making clear that each of those ranges is a range of test scores, and then we are also learning the frequency of them. So that makes this a little bit clearer. We're adding a little bit of information so the person consuming this, it's not just a random bar graph, it actually has some meaning to it. And so that's how we can make a histogram and modify it a little bit. Next, let's go ahead and look at some time series data. So we're going to make a time plot. So I'm going to scan over here to the left. I'm going to look at the Canton Massillon employment data. So what this has in it, scroll up a bit, it's all of these So these are months going all the way back to January of 2000, and this is the amount of employment in the Canton-Massillon Metropolitan Statistical Area that is tracked by the Bureau of Labor Statistics in the US government. And what I want to do is create a time plot that is a line graph that shows how employment has changed in this area over time. Now, there are a couple ways to do that. One thing that many people would find tempting is to just make this as a line plot. I generally advise against that. The reason for that is that sometimes your data will have time gaps in it. Say, I don't know, maybe there was a month you just couldn't get good data for or something like that. And the assumption in Excel is that every point along a line plot is equally spaced from every other point along that line plot, right? So that creates problems if we have any gaps. Now, a nice thing about an XY scatter plot is that it will look at the value of the x-axis, in our case time, so what month we are, and also the value of the y-axis, the employment, and then we'll plot that point. So if there are gaps, it's not a big problem. It just will be that there's a spot where you don't see a dot, and that's perfectly fine. Right, so the way we create this then, I'm going to highlight both month and employment. The way that Excel works, whatever the leftmost column is, it will treat as your horizontal axis. And that's exactly what we want here. We want time along the horizontal. Okay. So then we're going to insert again. And then right underneath the statistics chart is the way it's displaying for me. It may not always display the same way depending on how wide your screen is, right? But there should look like just a bunch of dots on a field. When you look at it, it says insert scatter. I'm going to click on that, and that gives me a few options. So here's what those look like. The first one is just going to show us a dot for each point. With line plot, with a time plot, you normally don't want that. Instead, we want those points to be connected because they are in a logical sequence. Right, so I have then four other options. So I could have ones that show the dots with a smoothed line connecting them. I could just look at the smooth line, so pull the dots out of it. That's generally better if you want to see the overall trend. I could look at the jagged connections with the dots or jagged connections without the dots. In my case, I think I'm going to go ahead and do jagged connections without the dots. That way the dots aren't taking up mental space for us. At the same time, the straight lines isn't going to create what looks like, I guess I'd say, falsely smooth data. So there's the scatter with straight lines. And again, I'm going to zoom out a little bit so we can see it. I can immediately see a problem. And that is all of our data is bunched up in this tiny piece of our graph. The problem here is that what it decided to do, it decided to automatically make 0, 0 the point that's in the lower left of this graph. And what it considers to be time 0 is January 1st, 1900. So we have roughly 100 years of data here, rather 100 years of space, before we actually hit our data. Now, a way we can get around that potentially is by doing something like this. Okay, so I'm going to type an equal sign here and choose that first date. Okay, now, naturally, it still says January. But I don't want it to be a date. Instead, I want it to turn it into a number because that's what it's transferring into. So I'm going to choose up here at the top where it says custom, right near the center and under the home tab. If I choose number, that forces this to be a number. So that tells me what numerical code fits the date for January 1st, the year 2000. Then I'm going to modify this axis so that it starts at that time, or at that particular number. So let's go ahead and double click on the horizontal axis. And that brings up my axis options. So you can see right here my bounds. It says minimum of 0, so that would be January 1st of the year 1900. I'm going to replace this with the number that I have here, so 36526. Hit enter, and there we go. Now we're starting in the year 2000. We're continuing over. It stops a little bit after the last data point that we have. That's not a huge deal. I'm just going to let that slide. Okay, so I've just adjusted what that looks like so we can actually see the data and how it has evolved over time. Another thing we could do, of course, we can add axis titles if we wish, right? So the dates are pretty obvious. So what I'm going to do, I'm going to add axis titles. I'm going to remove the lower one. So I just click on axis title till it highlights, so you see what looks like bold lines surrounding it. If I hit delete then, it will remove that axis title. I do want the axis title over here. So this is just the number of persons that are employed. And to be clear, it says employment at the top. It pulled that from the top of column B. I'm going to change this to Canton Massillon employment to make it clear where we're talking about the employment. Okay. This is a significantly better graph. Now, there are other things we can do. For example, I don't love these grid lines. I think they kind of get in the way. So if I click on one of those grid lines, I can delete them. Similarly to the vertical ones, I can delete. If you want to, so this looks like a much cleaner graph already. Uh, Now, naturally, this wouldn't help me get specific values out, but if you want the specific values, you read the table. You don't rely on the graph to get a very specific, detailed value. The next thing that I can do is I'm going to look at the possibility of adjusting this vertical axis, because as it is right now, we have a bunch of this vertical space that's not really telling us anything. So I'm going to double click it, right? And then you see it's bringing up, again, format axis. What I really want is the bar here to give me the bounds. So I click that, click axis options, bounds. You can see here it's starting at 0. Whatever our lowest point looks to be somewhere around, oh, actually, if I hover over it, it tells me it's 159,000 something. So I'm going to change that to 150,000. We'll see what that looks like. Okay, so that zooms in on the data a bit better. Now, even though I just did that, I'm going to undo it. The reason for this is that this is what we call rational data. Remember, the 0 actually means that nobody is employed. Right? So if you have 2,000 people employed, that is twice as many people as 1,000. And whenever we're looking at a graph for rational data, one thing that our minds tend to default to is interpreting this as if the bottom is 0. So when I look at this drop that happens, that's the COVID shutdown in March of 2000, my brain, when I first glance at it, I think, oh my goodness, 75% of people lost their jobs. Because it looks like we're going from this height to a height that's roughly a quarter of that. Right? But of course, that's not what happened. We didn't have 3 out of 4 people lose their jobs. A significant number of people did. They were prevented from going to work because of the shutdowns. But it wasn't nearly as much as what this makes it look like. Right? So having the bottom be something other than 0 tends to exaggerate what these jumps or drops feel like to us. So I'm going to go ahead and set this back to 0. So now sometimes though you will want to zoom in that way if you really want to emphasize those jumps or those drops. In my case, I think it makes it misleading right here. And instead, I want to look at the overall trend to see whether it's stable or not and kind of which direction are we going, what are the big changes we see. And I think we can see that here, I think much more accurately, that there's actually quite a bit of stability overall. All right, so that would be how to make a time plot using the XY scatter plot method. Yeah. There are other things you can do, right? If you really want markers in there, you can add them. Say if I pick a data point here, there's the possibility, click fill in line. So this is where you can change the line if you want. So if you like a different color, so this one's kind of a blue color. I could change it to something else if I want it to be red. I could do that. I don't particularly like putting red lines on there. It's makes it feel like I'm warning people of something. Or you can change the type of dashes if for whatever reason you want to do that. There is also the possibility of adding markers. If you scroll up here, there's also the option for marker, again under that bucket symbol. Right now we don't have any markers, so if I click marker option, you see it says none. I can put some in. I could say if I put an automatic, see it adds then what are circular dots, or if I choose built-in, then I have a number of options that I can use. Right? So I can say have squares or diamonds or triangles or the circles. I can choose their size as well, so I can make them bigger, right, or smaller as I desire. You can also choose how you want to fill them or not. So you could have them be just white circles or see-through circles or what have you. It's really up to you and what makes sense in your case. In this case, I think the dots are a distraction, so I'm going to remove them again. All right. So that would be time series, making it using the XY scatter plot method. Another task, so task number 3 we're going to look at is creating a box and whisker plot. So I'm going to look at a different set of data, right? Specifically this faculty survey data. As this faculty survey data came from a survey that I did of the faculty of my campus, where one of the things that I tracked was how long it took to be able to finish up this survey. Because sometimes it's useful to be able to tell people, oh, normally this takes like 5 minutes to do, or whatever it happens to be. Right? So you can see it automatically, the the survey software actually tracks the duration that it takes for people to do the survey. So I want to look at a graph of that. So to do this, I'm going to first highlight all the data. There we go. And then I'm going to choose Insert under Statistics Chart. So the same place we got the histogram in task 1, now we're going to look at a box and whisker plot. So we'll click on that. And again, we're going to zoom out a little bit so we can get a better sense of what it looks like. So here we have, right, each of these dots indicates an outlier that is something that is, in our case, unusually large. You can also sometimes have them underneath, but in this case, there was nothing that was unusually small compared to the rest of the data. The whiskers show you where the data except the outliers lie, so the edges here. So all of the points except for those three, right, fall within this range. And the box indicates where the middle half of the data is. There's also a little X in there that may be difficult to see, but the little X would be what the mean is. So the mean amount of time that it took somebody to do this. Now, again, you can adjust this if you wish. Like we could give titles. I could adjust the size of the axis if I wanted to. See, I can set the bounds if I wish. I'm not going to do that for this particular one. This is just another way that you can get a glance at what the data looks like. So it's in some ways similar to a histogram, but this one is really focusing more on where most of the data is and giving you that kind of information. Another piece of information we can pull from this would be task number 4, and that is to look at the descriptive statistics. Right, so I'm going to move this off to the side so that I can see the data again directly, and then I want to put in the descriptive statistics. So to find that, we click under Data. Off to the right here, you see I have something called data analysis. Data analysis has a number of tools involved with it, but first, before you do that, you have to activate data analysis. So let me go ahead and show you how to do that. So hop back into File, so that's the rightmost option, and scroll down. Now, in my case, I have it where it says More. Now, you might just have where you can already see something that says Options. So I click More, and then I choose Options. You might just see Options. And that will bring up a dialog box. Right, so let me go ahead and show you what that dialog box looks like real quick. That's what it looks like. You know what? I had this problem before. Actually, let me just do the whole. I'm just going to capture the whole screen to show you this one. Don't love doing the whole screen capture, but here we are. All right. So here's the entirety of my screen. See the studio I'm using for screen capture. All right. So here's what my options look like. So I need to go down about halfway to where it says add-ins. Click on that. It's like the next to last option. And that tells you a bunch of the different things that are available to you. So I want to manage these add-ins. It's near the bottom center where it says Excel add-ins on Go. And that brings up this option where I can check mark different tool packs. I'm going to use the analysis tool pack. If you want to activate Solver too, you can. These all just come installed. If you're working on a Mac though, I will say you have to look for a different place to find these settings where you can manage those add-ins. You may have to do a little bit of searching, but I think it's under a window like Tools or something like that. But again, you're going to have to activate it. So activate it, click OK. Once you click OK here, give it a second, and then data analysis should appear off here to the right of the data tab. So we've chosen data in our ribbon and then data analysis. So we'll go ahead and click on that and see what it looks like. Let me adjust this. Okay. So you're not having to look at the entire thing again. All right. So I'll show you what data analysis looks like. And we'll zoom in a little bit on it. So here's what the data analysis window is going to look like for you. It has a number of options available. Right, so you can see it has ANOVA, correlation, etc. What we want is descriptive statistics. So I'm going to select descriptive statistics, like so, and click OK. All right, so now that I have this, what it's showing me, let me double check to make sure this is all things you can see. Oh, I'm gonna have to make this a little bit smaller so you can see all the options available. So the first thing it wants from me is some kind of input, and that's where I have to select the data. The data analysis tools are not smart enough to realize that I've already highlighted something, so you have to open the data analysis tool and then go and highlight it. So I am looking at data that's in a column, specifically that column B. So if I click here, that's then going to allow me to select the data that I wish. So I highlight all of this, like so. Now, notice I did not grab those first three lines. The first three lines had the title, the column header. I don't want them in this case. I could have grabbed them and then I just have to tell it that it has a label in the first row, but you can only grab one row, and that the row that is just above the data was not very meaningful. The next option that I have is that I can choose whether I want to put the output in a new worksheet or whether I want to put it in the same one that I'm in now. And in my case, I actually want to put it in the same one I'm in now so I don't have to flip back and forth. And so I'm going to click output range, and then I again get to select where I put that. So I'll select down here. Looks like here, then it'll appear kind of below where that graph is. Then what do I want to have in those descriptive statistics? The thing that I'm looking for is summary statistics. I could also add a confidence level for the mean. We'll get to that when we talk about confidence intervals later on in the course. And then also kth largest and kth smallest. If you want to know what is the fifth largest or the second smallest duration, you can do that if you wish. It will show you the minimum and the maximum all the time. So then I'll click OK. And here's what we've got. Right, so it's showing me here's our mean, here's our standard deviation. It also has the median and mode. Gives us kurtosis and skewness, which we're going to be using in a moment. So there's all of those descriptive statistics that we'd be looking for the duration of uh, this particular survey. Okay, so that wraps up that particular task of coming up with these descriptive statistics. The next thing I want to do is show how we can use descriptive statistics to examine whether a distribution is normal or not. So I'm going to go ahead and switch over to a different set of data. We're going to go back to that test score data. Okay. So the test score data here, we already have this distribution that we've looked at. The second thing we want to do, let's add those descriptive statistics. So I'm going to select, first I need to go into data analysis, which is going to then give me the descriptive statistics option here, which is what I'm going to select, and click OK. In this case, my input range, I need to readjust that. So it's going to go from B2 down to, let's say it's like B107 or something. Oh, it is 107. I guessed well. Right. I did not include labels in the first row here. My output range, I want to have this be next to my data, so it's in between where I have my histogram and the data itself. And then summary statistics is what I want. Yes. So I click OK, and it calculates it all for me. So here's what I'm looking at to determine whether or not this is normal data. First thing, I would look at the histogram. Right? So this histogram, does it look roughly bell-shaped? Now, it's not going to be perfect most of the time. We should have a clear peak in the center of the data, and then it looks roughly symmetric on either side. Other things we'll look at is in the summary statistics, you want to look at the kurtosis and the skewness. Those two numbers should be fairly close to zero if you're dealing with normal data. Now, what does it mean by close to zero? One thing we judge by is it between -1 and 1? If so, then it's really close to zero for these particular measures. Now, some people would say you can go even further. I've heard some people suggest that skewness can go as high as 3 or as low as -3 and still be pretty close to normal, and kurtosis as high as 10 or as low as -10 and still be pretty close to normal. In this case, it looks like, yeah, this looks quite normal. We're dealing with numbers like -0.36 and -0.16. Those are really, really close to zero. On the other hand, if we go back to that faculty survey data and look at the skewness and kurtosis, now we're dealing with something that's different. Now it looks like we have right-skewed data that would indicate that we have some unusually high values, which we saw that in our box and whisker plot. We had those dots for people that took an unusually long amount of time to finish the survey. We also have a very high kurtosis. Typically, very high kurtosis would indicate something like there are outliers there, which we again know to be the case for this data. And so that's a fifth task that we can do is examine these types of descriptive statistics, and then the histogram as well. We could look at the shape of that to figure out are we dealing with normal data or not. Next, we want to create an XY scatter plot and add some trend lines to it. So we've already created an XY scatter plot for time data. Now let's do it for something else. So let's look at test data 2. This actually has scores, again, fake student ID numbers matched with test 1 and test 2 scores. So I'm going to insert a scatter plot here, very much like we did before. So I'm going to select C and a D, and then insert the scatter plot. This time just dots. Because the values aren't in here in any specific order, it doesn't make sense for us to connect them. Otherwise, we just end up with a jumble of lines. It wouldn't be very meaningful, right? So I'm just going to look at the dots. There we go. And that's what we've got. We'll zoom out a little bit so we can see this. So each of these points is a student. And that student has a combination of a test 1 score and a test 2 score. Test 1 score is what's on the x-axis, test 2 on the y-axis. So I'm going to go ahead and add in those axis titles. So we'll have test 1 score for my x-axis, and the test 2 score on my y-axis. There we go. And then I don't think I actually need a chart title anymore. So I'm going to go ahead and delete that. So this is showing me overall what the connection is, and then I can look and see, well, is it true that people that earn a higher score on test 1 tend to also earn a higher score on test 2? So I'd check the shape of this, and it looks like if I were to draw some kind of line in here to try to capture what on average is happening, it would be basically upward sloping. Well, you know what? I don't have to guess. I can actually add a trend line to this data so we can then see visually what it is that Excel says would actually be that best fit kind of relationship. So to do that, I'm going to click on one of these data points and then right click. And that allows me to add a trend line for this data. So I will select add trend line. And there we go. So it adds, you can see this dotted line hiding there amongst the dots. That is what the trend line looks like. Now, I can choose options for it, apart from just the formatting options. I can choose different types of trend lines. So if I think it's actually curved, I can throw an exponential in there or a logarithmic, depending on whether it's getting steeper or getting shallower as we move from left to right. I can also make it polynomial, so I can make it, say, U-shaped, V-shaped, have kind of a wave pattern to it, like a second, third order polynomial equation would. You can also throw in a moving average. This is normally useful for time data, so I'm not going to do that here. And then other things you can do, if you want to rename the trend line, you can do that. That's not really necessary. You can also, where it says forecast, what forward and backward does, it will extend out the line past your data. Right? So then you can make a guess. So, okay, if somebody got, say, a 40 on test 1 on average, what would they get on test 2? You can extend the line out. This is generally something I'm going to be real cautious about because we don't have data that goes out that far. Right? The relationship might change. You have another option, if you wish. You can set the intercept. So if, for example, you believe that 0, 0 is going to be a point that should be on your line, you can force the line to go through that point. The last two things I am actually going to do. One is to display the equation on the chart. So this tells you what would the equation of that line be in y equals mx plus b kind of format. Another thing you can do, back here, is we can display what they call the r-squared value. R-squared is a measure of how well this trend line captures the movement in the data, right? So it's really a measure of how much of the variation in whatever your y variable is can be explained by the trend line. So in our case, it's about 32% of the variation that we see in the test 2 score can be explained by this line that's really based on the test 1 score, right? So that's not too bad because lots of things go into test scores. So if you can explain roughly a third of a test score based on how you did on a previous test, that's some predictive power that we have here. But we do have to recognize that there is going to be significant variation around that. Your R squared will go anything from 0. 0 would indicate the trend line doesn't actually help us at all, and that's also going to be the case. Typically, you'll have a perfectly flat trend line with the data just kind of spread all around it to get an R squared of 0. You could also have an r squared as high as 1. 1 would indicate that every point falls exactly on that line. Okay. So, and naturally, most of the time, we're going to be somewhere in between. The next thing we'll do is create a correlation matrix. So this is one way that we can look for connections between data is to look at XY scatter plots and add trend lines into them. Another way is to look at the correlation measure. So I'm going to go to a different set of data. It's employment data here. So what the employment data shows is three different sets of employment. So one is for the US as a whole, the other is for Ohio specifically as a state, and then we look at the Canton area uh, specifically. Now, one point about this, the US data here, you can see it's in thousands. So this 143,292 is actually 143,292,000, whereas the employment data, that is actually basically 5.3 million people being employed, and this is actually 183,000 or so being employed. Okay, but what we're looking for is there a connection between these three? So the way we'll do this, go into data, data analysis, and then correlation is what we want. So I'll click OK. So I need an input range again. So I'm going to select all three of these columns, and this time I will include the labels. Including the labels for correlation matrices is going to make reading it a whole lot easier. So I click and I drag down till I hit the end of my data. All right. And then I do want to tell it has labels in the first row. Otherwise, it's going to look for numbers there and it'll give me an error. And I don't want to do that. I will add this to the same worksheet I'm already in. So I want to select, say I'll put it here right next to the data. And then click OK. Right, so correlation then will tell us how closely connected are these two different data series. So you notice here in the diagonal, we have ones. That indicates that US employment is perfectly correlated with US employment. All data is perfectly correlated with itself. So that's not a surprise. Similarly here, you see the row is Ohio employment, the column is Ohio employment, so Ohio employment is perfectly correlated with Ohio employment. On the other hand, when we look at, say, the US employment for the column and Ohio employment for the row, now the correlation is 0.91, 0.92, something in that range. Right, so this indicates a fairly strong correlation, but not nearly as perfect as a 1. So this just tells us that in general, these two seem to move in the same direction as each other and in an approximately linear way. Right? Then when we could look at Canton employment, it does have a positive correlations. That is, it tends to rise when one rises or fall when the other falls. But it does have a somewhat weaker connection to the US as a whole. Its correlation here being about 0.5, whereas with Ohio, it's a correlation of 0.76. So it's a little bit stronger for Ohio than for the US as a whole. This is another way that we can look at these connections and say, do these connections exist? Now, an important point about this is that correlation will only capture a linear connection. So we know sometimes you'll have a relationship that's, say, U-shaped or something like that. It looks like a U or like a mountain where it goes up and then down. Correlation would not capture that. It would just look like a correlation of zero because when it tries to stick a line on there, it'll end up with a relatively flat line and none of the points fall very close to it. So you end up then with a very low correlation, even if sometimes there is a very strong relationship. If it's not a straight line, you're not going to find it with correlation. The last one is last task is to run a regression. So this is one more way of looking at this relationship. So it turns out we already, kind of sneakily without realizing it, ran a regression. That's where this line for the test score data came from. So what we want to do is get a little bit more detail about that. So I'm going to use the same data, but instead I'm going to run what they call a regression here. Regression is just the method that we use to get the best fit for a straight line through this data. Right, so again, data analysis is where we'll find this tool. And then scroll down where it says regression. Now in our case, so we're going to have to input a y range and an x range. I'm going to choose test2 as my y variable, because that would match what we have in the chart. It also makes sense that if we're going to try to use this for prediction, people take test 1 before they take test 2. So we would want to use test 2 as our y that we're trying to calculate what it would be predicted to be. Then in our x range, right, so our other variable is going to be test 1, so I will highlight that. Notice here I am capturing the labels, so I will need to tell Excel that I'm using those labels. So labels, check that. I can force the constant to be 0 here if I want to. That'd be just setting the intercept at 0. I'm not going to do that. And I'm not messing with confidence level here. We'll talk about that later on in the course. I do want to choose my output range because I want to put it here in the same chart, but I'll put it in the same spreadsheet, but I'll put it underneath where the chart is. All right, and I'm not going to select any of the other options. Those are kind of advanced options that you may talk about when you're doing more advanced regression analysis. We're just doing simple stuff here to show what it looks like. Right, so this looks good enough to me. We're going to click OK. And here's the output it gives us. Right, so highlights from that. One is the R squared. So we already saw the R squared in the chart itself. Well, here you can have it displayed using the regression tool. We also have, if you scroll down a little bit further, right here's that equation for the line. So it says the intercept is 45.76 or so. Notice that matches, when we think of y equals mx plus b, that matches the b here, 45.755. And then our slope, right, so this, what it says for test 1, that coefficient on, and that is in fact what it says up here, 0.4583. Right, so these are just two different ways of getting to that same thing. The regression tool, though, is nice because it does provide some additional details that we will talk about soon. We focus more on looking at regression in a more detailed way. But this is just to get a first glance at what things look like. All right, so there we go. So I think that's it in terms of the tools that I wanted to show you. Right, so we got to see how to get a histogram, how to get a time series line plot using the XY scatter method. We saw a box and whisker plot. We found some descriptive statistics, examined whether we have normality in them. We used just a standard XY scatter plot, threw some trend lines in it. That's what we have on the screen at the moment, and also ran a regression to show how we get that equation. And then finally, we also created a correlation matrix to show how you can find these connections through that one summary number of the correlation. So until next time, have a good one.